Now we can also use the same canceling technique to solve some more story-related problems that are not necessarily conversion problems. If we go back to example number 1, here it tells us a piece of notebook paper is about 4/100ths of an inch thick. A ream of paper contains 5,000 sheets. How thick is that ream? Well, I'm going to start the same way I started this one. Take what I know, what they've given me, and let's try to convert it into what we need. Well, it wants to know how thick is a ream. Well, it told us that a ream was 500 sheets, so I'm going to start off with 500 sheets of paper. And if I wanted to, I could write that over one ream, or one, because that's what a ream is, a collection of paper. Times, it also tells us that one sheet of notebook paper is about 4/100ths of an inch thick. In fact, you know what? I think that's a typo. One sheet of notebook paper is only about 4/1000ths of an inch thick. So would you change that number for me, please? So no matter the number, the place where we put it is the same. I want to cancel out the word sheets, so I need to put that down here at the bottom. One sheet of paper is 4/1000ths of an inch thick. So now if I do the math, 500 times 4/1000ths, that turns out to be 2. 1 times 1 is 1. We really don't need that. That means the only label I have left is 2 inches per ream, which is how thick a ream of paper of this kind of paper is. Next problem talks about a calligrapher. Charges 5 cents a word to do fancy lettering. If a graduating class has 128 students, and each student has a first, middle, and last name, how much will the calligrapher charge to write the names on all the diplomas? Well, we want to figure out how much money. So when we get done, that's the only label we want to have is the money. But let's start with what we do have. We do know there are 128 students. So let's do 128 students and put that over 1. Times, what else do we know about students? Well, each student has 3 names. So I want to put students on the bottom so I can cancel out the label. So I can say one student has 3 names. So now if we do the math, we know how many names. But we need to know money. Well, it tells us here the calligrapher charges 5 cents per word. That's pretty cheap. So I want to put, a name is really a word, so we're going to say name on the bottom. Cost me 5 cents, 0.05. Now we're going to multiply our fractions together. 1 times 1 times 1 is just 1, kind of a waste of our time. On the top, if we multiply 128 times 3 times 5 cents, that turns out to be $19.20, which seems to be pretty cheap for all that work. Let's try one last example. If Donald reads 40 pages per hour, and her reads, sounds like another typo. Let's fix it. If Donald reads 40 pages per hour, and he reads 2 hours each day, how many pages will he read in 5 weeks? Well, we want to figure out pages, so that's the label we need to have left when we're done. And they're wanting us to start with 5 weeks. So we've got 5 weeks, and we need to figure out how many pages. Well, what's it tell us about weeks? Nothing. It tells us about days and hours, but what do you know about weeks? Well, I hope you know there are 7 days per week. So I want to put week on the bottom and 7 days on top. Now if we do the math, we'd have it converted into days. But I don't want to know days, I want to know pages. So it says that he reads 2 hours each day. So I'm going to put 1 day on bottom, 2 hours on top. Again, the days cancel out. So now I've figured out how many hours he would read. I don't want to know hours, I want to know pages. So the last rate they give us, 40 pages per hour, means 40 pages in 1 hour. Hours cancel out. So now it's all left. All we have our label pages was what we want. Multiply your tops, multiply your bottoms. Turns out to be 2,800 pages. So I hope you understand this technique that you can use to help solve problems when you are working with lots of rates.